Hello, fellow students, and welcome to this new lesson. Today we're going to work with finite automatons. So we will review the basic concepts of theory, and we will see a few examples of these state machines. So let me share my screen with you. And here we can see the different types of automatons that we have. The first one is the deterministic finite automaton. So this is a finite state machine. So that means that it has a finite number of states, and it can accept or reject a given string. So the characteristic of deterministic finite automatons is that each of the transitions is uniquely determined by its source state and input symbol. So that means that and also that reading an input symbol is required for each state transition. So let's see what that means, okay? To have the definition of an automaton, we need these 5 items. The first one is the alphabet that we will use. In this case, it consists on the letters A and B. Then we have a set of states, which is Q. Here we have Q0 and Q1. We have a transition function, which is not defined here, but you can see the different transitions. The transition function, in this case, takes a state and a letter from the alphabet, character from the alphabet, and it returns the state where you transition. So for instance, for Q sub 0 and the symbol, the character A, we transition to the state Q sub 0. Okay, then we have the initial state of the automaton, and here is Q sub 0. The initial state is marked by this symbol. You need to take into account that this is not a transition, right? As you can see, it has no associated character. This is just a symbol to mark which is the initial state of the automaton, right? It is the state where we will begin to recognize words. And then we have a set of final states. We can have one or more final states. And in this case, we only have one, which is Q sub 1. Here, the final states are marked by 2 concentric circles. So Q sub 0 is the initial state, and Q sub 1 is the final state. So as we mentioned before, in this kind of automatons, you need to have one transition for each state and each symbol of the alphabet. So that means that transition has to be unique for that state and symbol of the alphabet, right? That is exactly what deterministic means. It means that there is no ambiguity in where do I transition from any state with a given character from the alphabet. That means that here, if I have 2 states and I have 2 symbols of the alphabet, I will have 2 transitions for each state. So that means that it's 4 transitions in total, right? So we have transitions defined for A and for B in Q sub 0, and for A and for B in Q sub 1. Okay, so in total 4 transitions. And what is the language that this automaton recognizes? The language is any string starting by 0 or more A's and followed by at least 1 B, And then you can have any number of A's or B's, right? So it needs to have at least one B, right? Once that we read the character B, we reach the final state and we could finish, right? So for instance, the simplest character recognized could be something like this. Then we can have any number of A's before, or we can have any number of A's and B's before. So these are examples of the strings that this automaton recognize. To recognize a string, you need to be able to reach any final state from the initial state, just reading character by character and applying the transitions that you have in the automaton. So for instance, for this string, we would read an A, a second A with this loop here, a third A, and then the B. And we would end up in the final state. So that means that this string is recognized. If we had something like AAA, right? The string is not part of the language recognized by this automaton because we have no possibility to reach the final state reading the characters from this string, right? So we would do something like reading an A going from Q sub 0 to Q sub 0, reading another A going from Q sub 0 to Q sub 0, and reading the third A going again from Q sub 0 to Q sub 0. Right? So that means that this word is not recognized. We will complete more exercises on this later because we will go deeper in the definition of the transition function, which is the one that gives this information, the different transitions and the language that is recognized by the automaton. Okay, so the second type is the non-deterministic finite automaton, right? It's just a state machine that does not need to obey these restrictions that we have here. So that means that we don't need to have defined a transition for each state and each character of the language, of the alphabet that the automaton uses. So for instance, here, as you can see, for Q sub 0, we don't have any transition defined with the character B. And additionally, we have two transitions defined for the character A, right? So that means that this automaton is non-deterministic, right? Because it's not determined to where we go from Q sub 0 when we read an A, right? We could go to Q sub 0 or to Q sub 1, right? There is some kind of ambiguity there. And additionally, in Q sub 1, we don't have any transition defined for this state. And that's fine, right? So you can see the difference between these two types of automatons. And what language does it recognize? It recognizes the words starting by at least two A's, right? So for instance, AA, AAA, or 4 A's, or any number of A's. Sorry, I need, the minimum is 1, right? So this is the language that it recognizes. So for instance, if we have something like B, you can see this is not part of the language that this automaton recognizes because we don't have any way to reach a final state from the initial state reading the character B. This automaton is also defined by these 5 items that we have here. The other thing that changes is the transition function, as we will see later in the exercises. And finally, we have the non-deterministic finite automaton with epsilon moves. Let's say that it's a generalization of the former case, but we also have the transition function defined for the empty string epsilon. Right? This empty string means that we can move from q sub 0 to q sub 1 without reading any character. We could, as I mentioned, we could move without reading any character. So that means that if we have, for example, something like this, we could see that first, this automaton recognizes the empty string because we can go from q sub 0 to q sub 1 reading epsilon. It also recognizes all the words starting by A, right, and having at least one A, and then any number of A's as the previous one, but it would also recognize the words starting by B because we can read the character B, and then we can go to the final state reading the empty string. And then it would also recognize the strings starting by B and then having any number of A's or any number of B's, right? We could have several B's because we could read 4 B's and then we could go 1, 2, 3, 4, and then we could go to the final state. Then we have an additional concept, which is the epsilon closure, which means all the states where we can transition to from a given state using the epsilon, the empty string, using epsilon. So that would be q sub 0 because every state is accessible from itself using the empty string. And we would have also q sub 1 because we can go from q sub 0 to q sub 1. And in the case of q sub 1, it is only the epsilon closure is only q sub 1. So just to summarize, these are the main differences between the different types of automatons. In the deterministic, we need to have a transition defined for each state and each symbol of the alphabet. So here, with 2 symbols, we have 2 transitions for each state. In the non-deterministic finite automaton, we can have any number of transitions from an state with any symbol or any character of the alphabet. So we can have, like here, 2 transitions defined with A to different states and non-defined with B. And then when epsilon moves, we can move from one state to another. let's say, for free, right? Just reading the empty string, which is called epsilon. Additionally, we have the epsilon closure, which is all the states where we can transition from a given state using epsilon, which is the state itself, and also the epsilon transitions from this state. Okay, so these are the basic theory concepts. Thank you for joining me today. In the following lectures, we will complete some exercises regarding the different types of automaton, and we will deep our knowledge in these concepts. So thank you for joining me today. If you have any question, please don't hesitate to ask by email or in the comments of this video. Thank you, and see you again.